So today, Common Core is F for function, IF, interpreting functions, 7E, and it is to graph exponential functions and end behavior. All right. So, example 1. Let's just fill in the t-table, all right? So I'm going to go ahead and plug in -3, plug in -2, -1. I'm just going to use my calculator to do the work, right? So we'll go -3 parentheses. Actually, I'll clear that. Watch, -3. And right here, look, by the ln, you guys see it in blue? See the ln? Right there in blue? Can you guys see that? Right there, you'll see an e to the x. You guys see an e to the x right there?
Yeah.
So I'm going to go second e to the x. Now what I want to put is 0.5 times -3. Okay?
It's positive 3 dBs.
Oh, thanks, Marie. There you go. Thank you very much. Okay? So I've got my 3, my e to the 0.5 times -3. Everybody got it? Enter. About a 0.66, 9.67, 0.67. Okay, I'll do the same thing. 3 to the e to the x, right? E to the x. I'll go 0.5 times -2. How am I doing? Okay. And I get about a 1.1.
Mr. Davis, where's the per button?
The per button, the E button, right?
Oh, yeah.
Right there by the LN. You see that it's in blue by the LN? By the 4, kitty corner from the 4 in blue. Do you see this LN button right here? Here, do you see this? Do you see this LN right here? Okay, you see the LN button? It's right there.
Okay.
It's right there. You see it? So let's do it again. Let's go 3. Hit my E button. 0.5 times -1, right? I get about a 1.8. Three, hit my E button, 0.5 times 0. I get 3. That actually made a lot of sense to me because anything with 0 power, regardless, is always going to be the number 1. It's 3. Then I'm going to go 3, hit my E button, 0.5 times 1, right? How am I doing? You guys good? I got about a 4.9. I'm going to go 3, E button, 0.5 times 2, about an 8.2, or a 1.5, doesn't really matter. This 0.3, hit my E button, to the 0.5 times 3, 13.4. Okay, make sure you can do this. Make sure you know where, like I liked how Elijah asked where the button is, because you need to know, right? If you don't know where the button is, it's, it is right there, okay? The E button's right there. So if you want to do an E to the power, use this. If you want just the plain old E, the number E, it's right here. If you want just what the number E is, that's that button, E. But if you want E to some power, you've got to use this button, okay? Everybody see the difference?
Yes.
All right, now, let's graph this. So, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's way up there, right? 1, 2, 3, -1, -2, -3. Ah, boy, 0.6 is hardly anything at all, but it's maybe a little smidgen of 1 there. 1.1 is a little bit bigger, right? 1.8, a little bit bigger. 3, wow, okay, we're all the way up to here, so it must be off by a little bit. 4.9, there's 4.9. 8.15, so 1, 2, 3, 4, 5, 6, 7, 8. And it curves just like the others did, because it's also, whoops, I missed that, because I got to go through 3. I do have to go through 3. It's got to go through 3. Okay. Same question as yesterday, will it ever cross the x-axis? Will it ever cross the x-axis? No. It will never touch the x-axis. And that changes the range. Since it never will touch the x-axis, the range has just got to be y is greater than, thank you, Marie.
Wait, why didn't it go through 1? Oh, wait, no.
It's got to go through 3, right? Yeah. So the range has got to be y is greater than 0, okay? Because it never touches the x-axis. It's always above 0. But the domain, we plugged in a lot of numbers, right? We can plug in any number. Yeah, you can plug in any number, so all real numbers. Okay, domain x equals all real numbers, okay? Okay. Now, yeah, negative exponents. What's going to happen with a negative exponent? Let's try the next one, okay? So the next one, plug them in again. I'll go 4. I hit my E button. To the negative 3, which is really like to the positive 3, right? So about an 80. Well, that's a big number. I'll go a 4. I'll do my E button. And negative 2 is really like putting it to the second power, right? 29.5.
Wait, did you say negative?
Yeah, negative makes it positive, doesn't it?
Okay.
You agree with that?
Yeah.
And I'll go 4E, and I'll go negative 1, which is really like a positive one, right? About 10.9. To the 0 power, it's going to be 4. You can try it, trust me. I know that. Anything to the 0 power is always 1, right? We'll go 4. We'll go E to the negative 1, right? It's about 1.47 or 1.5. We'll go 4. Use our E button to the negative 2. About 0.5. We'll go 4. Use my E button, E to the negative 3. And I get an answer about 0.2. Okay? Okay, let's see if we can make a graph of this. All the way up to 80. Well, I better go 10, 20, 30, 40, 50, 60. Better extend this. I gotta get all the way up to 80, don't I? 70, 80. 1, 2, 3, negative 1, negative 2, negative 3, right? So negative 3 and 80 is way up here, right? Negative 2 and about 30, it's about 30. Negative 1 and about 10. 0 and 4. 1 and 1.5. Just get smaller and smaller. So same thing, it's going to get smaller and smaller and smaller. However, it's never going to reach 0. There it is. Range, right? Range, it never reaches 0. Never touches 0. So it goes up from 0, so it's going to be y is greater than 0. And domains, all real numbers, right? It can be anything. So domains, x equals all real numbers. Obviously, this is an example of growth. And decay, right? One's growing and one's getting smaller, okay? Alright, you guys ready to turn the page? Okay. Turn the page. Okay. So example 3. An infectious disease spreads from 10,000 people and then spreads per day the following formula. Okay, so like most diseases, especially like a flu, initially you see a lot of people get sick, right? And the population becomes greater and greater. And then people start to get well, and then it starts to level off. Does that make sense? Okay? And then eventually it'll start to come back down, right? So let's see what this graph looks like, okay? So how many people are affected at t equals 0? So let's see if we can plug in 0. So we're going to need to use our calculator. It's a little tricky to put in, but let's see if we can do this, okay? So to use my calculator, I'm going to go 10,000. Divide by parentheses. You okay with parentheses? 5 plus 1, 2, 4, 5. E power, right? E power. Negative .9, whoops, 97 times 0, okay? Parentheses, parentheses. I gotta have double parentheses, okay? Enter. 8. What does that mean? What does the 8 mean? 8. What does the 8 mean? Well, in Leavenworth, it means that 8 darn tourists came over to our town, sick from Seattle, and spread the disease in our cute little town, huh? That was our initial people. Initial amount. Okay, 8 people, that's the beginning amount. So that's our first glimpse. At T equals 0, 8 people come to Leavenworth. They're all kind of packed in a van. They're all sick. They get out, and then we start to get sick, all right? All right. Or like on an airplane. Same thing. You get an airplane, right? So find the number of people infected after 1, 2, or 5 days. So one of the things that would help me, this is the way I would prefer to do it, it's kind of a pain to plug in. We have to graph it anyway. If we could put the graph in the calculator and see what it looks like, then we can use the trace button to get these answers. Okay? So I'm going to try and graph this. So I'm going to go to my y equals, okay, clear. And let's see if I can do this. I can go 10,000 divided by parentheses. Got to use a parentheses so the entire bottom's on the entire bottom, right? 5 plus 1, 2, 4, 5, my e to the negative 0.97x, because you can't do a t, parentheses, okay? Okay, now if it's in my calculator, I'm going to graph it. Let's find out what happens. Okay, ready? Graph. Okay, well, this is all I see. This is not a very good answer, because if this is time 0 here, this is negative time. That didn't tell me anything. Maybe we can adjust our window. What do you think? Let's go to our window, and what do you think? Maybe a lot bigger, right? So I think more than 10 people are going to be infected by the time we're done. What do you think we should put in for how many people? How many?
5,000.
5,000? 5,000 is not a bad guess. Let's graph it, see how it looks at 5,000. Ah, 5,000 was good. Because it starts to level off, right?
Increase our x value.
Yeah, let's go increase our x value so we can see how many days. So I'm running this for 10 days, but maybe it's going to take longer for 10 days for this whole virus to clear. So let's go change my window to say maybe 20. Okay. Right. Okay, pretty good graph. Looks like it's leveling off, doesn't it? So I do know that way down here, if I make this 10, I can put a dot at 8. I know for sure 8. Do you know why I know 8? Because of that, right? I know 8 for sure for here, right? Let's put some numbers in. Let's go trace 1. So trace, so if I go t equals 1, if I go to my trace 1, so after 1 day, about 21 people are infected. Okay? Let's go t equals 2. Trace 2, about 54 people. Let's go 5 days, and I get about 678. Now, what about end behavior? Isn't it leveling off? Seems to level off, right? Seems to hit our town and level off, and then if you've got the right immune system, then you don't get sick, right? You know how that works. Some of us happen to have the right immune system. Duncan, he's going to survive because he's sleeping anyway, so, you know. So if I just use my button and I keep going, okay? Let's see what it levels off to, okay? Okay, what do you think it's going to level off to? Take a look at my numbers. What's it going to level off to?
2,000.
2,000, right? So in this population, about 2,000 of us will get sick, and the rest of the population are immune to it, right? Yeah, that's pretty much all of Leavenworth, right? Yeah. So end behavior, it's going to level off to 2,000 people, okay? So let me put a 1,000 up here. I'll put a 2,000, right? And we'll go our 10 and our 20. And we do a little bit of a dot to dot. We know that at 54, 5 is here, and then it levels off. So it's going to go up like this and level off at about 2,000, okay? And that becomes actually a horizontal asymptote. So what's the range of this function? Well, it's going to be from 8 population to 2,000. Does it ever reach 2,000? In theory, no. In fact, you can keep going and waiting and waiting. You can wait forever. You can wait forever to see if it ever reaches 2,000. Actually, the calculator probably does eventually.
26.
Yeah. Okay, I'll put an equal there then. Okay. Okay, last example. Landon has $10,000. Of course, he'd rather go to Hawaii than to college. That's Landon. But that's okay. You know, he's going to go to Hawaii after he graduates and get a job singing in some nightclub. That's what he thinks. That's awesome. Okay. But before he can go, Dad's going to take his money. I'm going to put it in the bank and make him save it before he takes off. All right. So he goes to 3 different banks. Bank A will offer him 3.7 compounded annually. Okay. Bank B is compounded quarterly. And Bank C is going to do it for continuously, okay? So I'm going to do the work on the side because I'm going to run a room. So Bank A, let's do Bank A first. Bank A is going to be our 10,000. 1 plus 0.0375 to the 5 power. Compounded annually, okay? There's no n. There's no n involved in this. In fact, we saw this formula yesterday. Okay, so we'll go 10,000. 1 plus 0.0375 to the power of 5. So Landon, let's see, he's got about $12,020 and about 99 cents. They might round that up to $1. You never know how the bank is, right? Quarterly. Okay, so now Landon's going to say, okay, well, I'm going to take it over here. They'll compound it quarterly, okay? So we'll go our 10,000, 1 plus our 0.035 over 4 to the 4 times 5, right? That, we used that formula yesterday also, right? All right, let me use my calculator and find out how much money Landon's worth. 10,000 parentheses 1 plus 0.035 divided by 4 to the power of 20, right? How am I doing? Good? All right, so Landon's got 11,000. So this time he's got less money, but he didn't get such a good rate. $11,903.39. Okay. Bank C, 3.25 with compounded continuously. So he's thinking, hey, Dad, this is a great deal. It compounds my money all the time. But Dad's going to say, well, which one has the highest interest rate is what I'm going to say. But he tries anyway, so we're going to use this P formula. We can use our P e to the RT formula, right? So Landon's going to go 10,000 e to the 0.0325 times 5, right? That's a times sign. So let's use this calculator. We're going to go our 10,000. We're going to go e to the x, right? E to the 0.0325 times 5. And he makes about $11,764.48. So Landon comes to Dad and says, Dad, how come we made less money? I mean, it compounds more. I'll say, son, that's because it's the interest rate that makes the biggest impact, okay? How's that? Easy? You will have a question exactly like this on Friday's test, okay? Exactly. Different numbers, but the exact same process, okay? Positive. I wrote the test. I know it's on it. Yeah, okay? So homework, here it is. 341, 5, 6, 23, 24, 29, and 37.